We have another DC-DC converter here. This is a 12 volts input and the output is symmetrical. So these are output plus or minus 32 volts, and the output of this, I believe, is unregulated. So if the input voltage varies, the output will also vary a little bit, and the output of this one is not adjustable. This is our input side here. We have our reverse protection diode, then we have our filter cap, we have an inductor, another filter capacitor here, and we have our bypass capacitor, and we have 6 output filtering capacitor here. It says Nichicon 3300 UF 50 volts. There's 6 of them, so 3 each side, 3 per rail, 9900 UF per rail. And this is our PWM chip here. This is an old school TL494. This is our driver transistor. There's 2 of them, 2SA1015, and this is our driver. This is the driver. There is 4 of them. IRFJ44N, and this is the secondary output rectifier. This is rated at 10 ampere per leg. So each of this diode is rated at 20 amperes. This converter is the output of this converter is isolated from the input. This is the ground. Yes, this is the ground. Goes to this pin, and this is our ground here, and this output ground. So the output and the input ground is isolated. This is the output secondary rectifier. This is the secondary winding of the transformer. So this is the secondary output winding. It goes to this one. I think this is the positive rail and this is the negative rail. This one should be going to this side of the pin here. Let's see. Yes, and it goes to this. And this one goes to this side and this side. Should be the negative. Yes, this is the negative output. This is the positive output here, the center. This is the ground. So this is the input winding of the transformer. This one goes to the positive, to the input, to the supply line. This is the coil here. This is the coil. Goes here. So these 2 drivers are in parallel. You can see here, they are in parallel. Same with this one. Now we're gonna look at the specs of this from the listing. So this is the listing page of the DC-DC converter. It costs about $12.91, and shipping is around $8. So it's about $20.91. This one is sold by Mr. Board. It says 12 volt to 30 volt. this is the specs of the converter. This is what we're interested in, 180 watts. So we're going to test this power supply, this DC converter, if this can deliver 180 watts. I have now attached some heatsink to the board. Let's see if there is no short between the transistors. Good. The output rectifier has an isolated tab, so there's no need for insulation like this for here. I have the DC-DC converter now connected to our power supply. This is our power supply here. This is our 12 volts power supply. It is adjustable up to 15 volts, and it's connected to our electronic load. Currently, this is our input to the DC-DC converter. This meter is connected to the output of the power supply directly. So that's our input 12 volts, and the output is around 30.9 volts on the positive rail and 30.8 on the negative rail. This board is rated for 180 watts, so this should be able to deliver around 3 amperes. So that is 180 watts. 180 divide 60 volts. So this board should be able to deliver around 3 amperes. So we're going to try 1 ampere first, and then go straight to 3 amperes. But first we are going to look at the ripple of the output ripple of the DC-DC converter. This is the no load ripple. You can see it here. This is the peak to peak, around 20 millivolt. Now we're going to put a 1 ampere load. Okay, that is 1 ampere. Start on. Yes, that is 1 ampere load. The voltage has dropped to 28 volts. So we lost about 2 volts. Okay, and this is our ripple. Okay, so this is our peak to peak ripple with 1 ampere load, around 1 to 8 millivolts. Okay, let's go to 3 amperes. Okay, I have a fan blowing directly to the heatsink here, because I think this heatsink is a bit too small for this board maximum load. Turn this off first. 3 amperes. Okay, so the voltage has dropped to around 26 volts. The output of the power supply is very stable, still at 12 volts. Now let's look at the ripple. Okay, so our ripple has increased to around 300 millivolts plus. Now let's increase the output of the power supply to 14 volts to get an output of 32 volts. First, I'm going to turn this off and adjust the power supply. Bar adjustment part here, this voltage adjustment, and this for the current. I have set the output of the power supply to 14 volts, and the output has increased to 36 volts. So we're going to test the output at 1 ampere and 3 amperes. At 14 volts input, the output is 33 volts with 1 ampere load. That is the ripple around 120 millivolts peak to peak. Now we go to 3 amperes. So So this is our voltage, current, and the wattage. Okay, with 3 ampere loads, the voltage dropped to 31 volts. So we have about 93 watts here per rail. So that's around 186 watts. And the ripple is 300 millivolts plus now. So this board is able to deliver its rated rating of 180 watts with an input of 14 volts. The output is around 31 volts. Now I'm going to connect this DC-DC converter to the amplifier, and we're going to look at the output of the amplifier if there is any noise. I have the DC-DC converter connected to our amplifier here. I'm going to check the scope here if there is any noise coming from the amplifier. Let's turn it on. So that's the output. It's very clean. I'm going to reduce the output. Currently we have 0.1 volt input to the amp, 0.09 volt. The output is very low. Okay. Trigger. Just the trigger. With no input signal, there's actually some noise. In the output. Let's look at there's some low level noise coming out from the amplifier around 200 millivolt. That is a high frequency noise, so probably the the dividing network of the speaker will take care of the noise. So that's 1 kilohertz signal. Let's see how much power can we pull from this DC-DC converter. Volts per division. That is 56 volts peak to peak. We have an 8 ohms load connected to the amplifier. That's our input, 2.2 volts peak to peak. So it's clipping now. That is 2.2. It's clipping a little bit. We have an input of 2.1 volts peak to peak. And the maximum output before clipping is 58 volts, 58.4. 38.4 by 2.828 squared divide 8. So that's about 53 watts at 8 ohms load using the LJM MX50 with this DC-DC switch mode boost converter. So you can use a battery to power your amplifier. With this board, you can probably power to LM3886 with this one board. Okay, that's it for today. Thank you for watching. See you next time. Please subscribe.